All right. So our longest chain, continuous chain carbons is 5. We want to number right to left because that'll make the double bond come off the second carbon rather than coming off the third carbon if we go left to right. So when we number this, we're going to go 1, 2, 3, 4, 5. Okay. So my base name 5 is pent, right? It's another double bond, so it's going to be pentene, and it's off the second carbon. So it's 2-pentene. And then what groups do I have attached and where?
2, 4, dimethyl.
Right. So 2 different methyl groups. So 2,4-dimethyl-2-pentene. I also want to point out that there is a newer IUPAC is the organization that develops rules for naming. And they did come up with a newer system where instead of saying 2-pentene, you might see it 2,4-dimethyl, and then you might see it written this way, pent-2-E. So that's an acceptable way. It's a newer way of naming it, but both naming systems stick around. So in some references, you'll see it 2-pentene, and other references you might see it pent-2-ene, just showing where the double bond is, because the ending, the ene, is the double bond. It's putting the number right in front of it. Does that make sense? You might see it. All right, let's go to this one. What's the longest chain you can find here? And it has to include the double bond.
5.
So it is a 5 chain. So again, we can just go across. And which way are we going to number this one?
Right to left.
Right to left, because our double bond's here. Groups that we have attached. We have 2 methyl groups, right? And then we also have ethyl group. Which one are we going to put first? Since we have methyls and ethyls, how do we know which one we're going to put first?
Ethyl comes alphabet.
Right, we go alphabetical order, ethyls before methyl. So we have 3 ethyl. And my methyl groups are on 2 and 4, right? So 2,4-dimethyl. And then since it's a 5-carbon chain, pentene, and it's off the first carbon, right? So either 1-pentene, or again, you might see it as pent-1. Both acceptable. Questions on that? We'll go to this one. What's my longest chain here? Still 5, right? Even if I start here and go over, it's still 5.
Left to right.
Correct. Or no, actually, the double bond is going to come off the third carbon either direction, right? 1, 2, 3, 1, 2, 3. So if that's the case, then you want to look at where your attached groups are going to have the smallest. So we're going to actually go right to left. first look, I thought it was off the second carbon. And then again, we have a methyl group and an ethyl group, right? So we're going to make the ethyl first. So 3 ethyl, 2 methyl, and the double bonds off the third carbon, 3 NT, 4. Coming down here, which way are we going to number this one? I think it's obvious that this is our chain, right?
Yeah, right. Or oh my god.
Left to right, there's our double bond, right? So the double bond takes precedence. And then we just have methyl groups off the third and fourth carbons, right? But we have 2 different ones coming off the fourth, so you have to write 4 twice. It's going to be 3, 4, 4. Trimethyl. So third, fourth, fourth. Trimethyl. And 1 pentene. 4 hexane. Here again, let's go straight across. Which way are we going to number it? So double bonds here,
What or left to right?
left to right, 1, 2, 4. We have 2 methyl groups, so it's going to be 3, 3 dimethyl. 1, and since it's 4 carbon, it's going to be, or the but 1E. All right, so here we need to find our longest chain that includes the double bond.
The end of the like the end of the base, like the base straight away, and then slants down.
Right. So the longest continuous chain of carbons that includes the double bond is there, right? Okay.
Right.
Yep. 1, 2, 6. We have a methyl and an ethyl group. So again, we're going to start with the ethyl because alphabetically it's first. 3 ethyl, 2 methyl. Off the first carbon, 1, 1, 2, 3, 4, 5, 6. So a base for 6 is
Hexene.
X. Or X1. Just remember around the numbers, you always have dashes. All right, the next one.
Straight.
I don't remember that one.
Right.
Left, that's what gives us the lowest double bond. Total of 7. here we have two methyl groups, two ethyl groups, and three methyl groups, right? We'll name the ethyls first, and they're both off of our fifth carbon. So it'll be 5,5-diethyl. And then 2,2,3 trimethyl. And what's 7? Heptene, that's off the third carbon, right? So 3 heptene. 5,5-diethyl, 2,2,3 trimethyl, 3 heptene. Get those. Then on the back, you had to draw them. They gave you the formula and you had to draw them. I don't really think they're going to be on the final exam that way because the final exam is set up mostly, I think that you do multiple choice or type in an answer. So I'm pretty sure they're going to have the structures there and you just have to like pick the right structure. They might have the name and then pick the right structure, but they don't actually have to draw them. But let's go through those anyway. There is a mistake on the last one. The name they gave you is not correct once you draw it. You can draw it from that name, but it's actually named a different name. So you can see if we can figure that out. So anybody, do you guys want to come and draw those? If you didn't do them yet, you can work on them and draw them in order. See if you can draw them out based on the name. And that very last one, well, after we draw it, we'll see that it's actually named differently. Pause this. Okay. Two ethyl, 1. So we made the pentene, the double bond off the first carbon, ethyl group off the second carbon. To get the hydrogens, every carbon has to have 4 total bonds around it. So we figure out how many hydrogens we need by how many bonds the carbon still has. So this carbon already has 2 of its 4 bonds, right? It's a double bond. So we need 2 hydrogens on this one. So that's going to be a CH2. This carbon has all 4 of its bonds, so we don't need any more hydrogens on that one. This carbon has 2 of its 4 bonds, so it's going to be H2 because we need 2 hydrogens then. This carbon only has 1 of its 4, so that's going to be H. And this carbon has 2 of its bonds, so we need 2 hydrogens to go with it. This has 2 of its bonds, so 2 hydrogens. This only has 1 of its bonds. So that would be the correct structure for 2-ethyl. Someone might argue that, hey, we could get a longer chain this way, but you have to include the double bond in the longest chain. So that's the longest chain that includes the double bond. Two, 3-dimethyl 1-butene. Again, when you draw these, I work backwards. I look at what my base is and then I attach my stuff to it. So butene, how many carbons are we going to have? 4. And the double bond is off the first carbon, and I have methyl groups off the second and third. And we have our hydrogens. This has 2 of the 4, so it's H2. Does this need any more hydrogens? Nope, it has 4. This one,
Or two.
actually we need 3, right?
Oh.
Because it only has the one bond there.
Right.
So 3. Same thing here, right? This one,
Oh, that's good.
Nope.
Oh,
one,
you need one more.
just 1, right? And this one.
On three.
So that's the 2,3 dimethyl 1-butene. And I said that we also want to also draw these using like the stick models. So on this one, if I'm drawing this using the stick model, I have 1, 2, 3, 4, 5 carbons in my chain, right? So what we do there, the first point is a carbon, right? Every point's a carbon. So 1, 2, 3, 4, 5 is my chain. To indicate a double bond, you just simply put another line like that. That's just showing that it's a double bond between these carbons. And then we have an ethyl group coming off the second carbon, so I need like 2 points there. So off of the second carbon, just do that. Does that make sense? So on this one, I have a 4 carbon chain, so I'm just going to go 1, 2, 3, 4. And my double bonds off the first one. So I'm just going to draw a line that way. And then I have a methyl group coming off of this one and this one. So you just draw a line. 2, 3, 4 trimethyl hexene. Okay, hexene, how many carbons?
6.
It's off double bond again, it's off the first carbon, and we have methyl groups off second, third, and fourth. All right, how many H's do I need on this first carbon?
2.
2. Give myself 2. How about this one?
1.
It's already got 4, right? 1, 2.
Oh,
3,
that's
4.
good.
This one I need just 1, right? This one I need just 1.
2.
Last one, 3. Okay. And again, if we were drawing it stick-wise, we have 6 carbons. 1, 2, 3, 4, 5, 6. Double bond again is off the first one. And then I have methyl group, methyl group, methyl. Now this last one, this is the one where they don't have the correct name. We can draw it from this name, but it's not the correct name. They have 2 ethyl, 3, 4 dimethyl, 2 pentene. So again, working backwards, let's do the pentene. We have a 5 carbon chain. And they're telling us the double bond is off the second carbon. There's also an ethyl group coming off the second carbon. Methyl group coming off third. And again, it doesn't matter if you draw them up or down because it's a 2-dimensional draw. Then I'm just going to stick my hydrogen there. 3 here, that here, down there. So this name actually is not correct. What is the longest continuous chain I can put up there with the double bonded?
6.
6, right? Because we could actually go up this way and get a longer continuous chain. So this name actually is not correct. That's on your sheet there. Now, as far as numbering it, it's going to be off the third carbon either direction, right? 1, 2, 3, 1, 2, 3. So now we go to the groups, and we want to have it so that the ethyl and methyls are off the lowest possible carbon. So if we go right to left, it's off the second, third, and fourth, right? Or actually, it's 3 methyls. I'm sorry, it's 3 methyls. There's our 3 methyl groups. So go with me. So if I number left or right to left, my methyl groups are off my second, third, and fourth carbon. If I go left to right, they're off my third, fourth, and fifth carbon. So I want to go right to left. So when we name this one, it's going to be 2, 3, 4. Trimethyl. And it's the double bonds off the third carbon. Does that make sense? And then again, if you want to draw this using the stick model, I have 6 carbon chain, 1, 2, 3, 4, 5, 6. Double bonds off the third carbon. So 1, 2, 3. Means it's coming off the third to the fourth. And then a methyl group off my second, third. It doesn't look the same as one up there, but it's really the same. It's just because they're flat. That makes sense. Then for the rest of the time, if you want to work on either finishing that alkane packet or working on your final exam reviews, I don't care which ones you do. When you're working through the final exam reviews, though, please circle the ones that you're unsure of, and we'll go over any of those that you have uncertainty about, or that you just need kind of a refresher. Okay, so we have a fluorine attached off the first carbon. There's 3 carbons. What's the name of the 3 carbon alkane? Propane, right? So this is 1,fluoro propane. So again, we just drop the ene ending off fluorine and just put fluoro. 1,fluoro. I just put the ones up here that involve halogens. So this is on page 6 in that packet. These at the top, these down here that we're going to draw are off page 7. So here we have another propane, right? It's another 3 carbon chain. But which carbon is the bromine off of?
The second.
Second. So we're just going to say 2, and then it's bromo. 2 bromo. Okay. Makes sense. And then if you draw these using the stick model, you just put a line up with the halogen. So this one's kind of hard to draw stick model. It's just a line, right? But you would just draw a line off of it saying that there's a okay, here we have 3 carbon chains, 1, 2, 3, and it's off the end carbon. So you just put fluorine like that. 1, 2, 3, and it's off the second carbon. So you would just draw it All right, then they gave you the same exact one that's up here, chloroethane. So again, you're just gonna draw ethane. But you're gonna put the chlorine off of one of the carbons, it doesn't matter which one. So I'm just gonna say CH2. So chloroethane, it's chlorine that branches off. So this is H2 because we already have 1 and 2 bonds. So we only have 2. 1 fluoropropane. Again, they gave you the same one as what was on the previous page. Just take it. Oh, it's 1. I'm sorry. I was thinking 2 fluoro. I'm sorry. And again, it doesn't matter if you take the fluorine up, down, or over. It's the same. So, look at me, this is one day, right? That's it. Yeah, so apparently for some of these, they gave you the exact same one. They just had to draw them, but they were already on the previous. Super appropriate. Now the other ones they didn't give you, obviously, so they're not the same ones. I don't know why they repeated the same. I guess maybe to see that do it both ways. I don't know. So here we have 2-chloro-3-methylpentane. So again, it's a 5-carbon chain. So we can put our 5 carbons out. There's a chlorine off the 2nd carbon and a methyl group off the 3rd carbon. And you just put your hydrogens in. So this one still needs 3. This one has 3 bonds, so it's 1. This one has 3 bonds, so it's 1. And then the last one, this is where you can kind of see, I think, that the chloro group takes precedence over the methyl group. So we have 2-chloro-4-methylpentane. So again, it's a 5-carbon chain. Chlorine off the 2nd, methyl off the 4th. But you can see, like, if we numbered it this way, it would have been 2-4 the other way, right? 2-methyl-4-chloro. But the halogens take precedence in the numbering. So that's where this one, even though it's off the 2nd and 4th carbon either direction, you want the halogen to have the lowest possible number. So we have to go left. So that's where the 2-chloro comes from. Carbon numbers in the subscripts. And again, if we were drawing it using the stick method, 1, 2, 3, 4, 5, you'd have a chlorine coming off your 2nd, and for the methyl group, you just draw a line. Sure, it's understood. Any questions on this? Does that make sense? And of course, if there's a double bond that has a halogen, it's the same. The double bond still takes precedence. But you just use chloro. just a reminder on a few things with those before I let you just work on the definitions. Do you remember what the general formula was for the alkanes? CN, and what did we do to get the hydrogens? Right. Double the carbons and then add 2, because remember you have the 2 hydrogens coming off the ends. All the middle carbon. That's when nothing's attached to it, right? So like when you have butane. Okay, the middle carbons, all the middle carbons in the chain just have 2 hydrogens, but then the end carbons have those extra hydrogens. So that's where that comes from. So let me draw it structurally. I don't think we talked about the alkenes, what their general formula is. So I think it's easy to see with the alkanes, like there's 2 hydrogens coming off all the middle carbons. There's 2 hydrogens coming off the end carbons plus 1 more on each side. So that's where the plus 2 comes from. Got CH2 plus these 2 additional. If I form a double bond, the only way a double bond can form is if I get rid of 2 hydrogens, right? So if I want to form a double bond between 2 carbons, these are all saturated, right? The alkanes are what we call saturated. When we're talking about that. They're saturated because nothing else can attach to it. As much stuff is attached as possible. That's where saturated is. If I want to make a double bond here, I have to unsaturate it, right? So if I get, let's say I get rid of that hydrogen and that hydrogen. If I do that, that frees up a bond for each of these carbons. And now I can form the double bond here. So what we end up with if I get rid of these 2 hydrogens, now I can form the double bond between these carbons. So what do you think the general formula for alkenes is going to be? Had to get rid of how many hydrogens? 2. So if I'm getting rid of 2 hydrogens, what's that going to do this one?
Just be HN plus 2.
No. I'm just getting rid of 2 hydrogens. If I subtract 2, what am I going to do? Just subtracting 2 from that.
Oh, just be 2N.
2 men. So in alkenes, you always have double the number of hydrogens than carbons. And that's because to form that double bond, it had to get rid of the 2 hydrogens. But if you count them, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 here. So we see 5H10. And we didn't talk about alkynes, and I don't know if they'll be on your final or not, but you name them the exact same way as alkenes. It's just that you have a triple bond. So what you do when you name them is you just put a Y in here. So if you have a triple bond, we have to get rid of 2 more carbons, or 2 more hydrogens, I mean, to form that triple bond. So we have to subtract 2 more carbons from this. So if you have alkynes, it's just going to be 2N minus 2, because we have to get rid of 2 more hydrogens to form that triple bond. And the way we name this, it's the exact same way we name these. Okay. This was 2-pentene, right? This one's just going to be 2-pentine. All you do is just change the ending. And the other thing I wanted to make sure you remembered about these is isomers. Do you remember what isomers were?
So like individual versions of.
That's isotopes. Okay, so that iso prefix, that's what we were talking about, the iso prefix. Something's the same about them, but something's different about them. So like isotopes, that's where we have atoms with different numbers of neutrons, right? But same number of protons, same atomic number. So isomers have the same molecular formulas as different structures. So if I wanted to draw, let's say I wanted to draw isomers of pentanes. Okay. One way I can draw pentane is just go straight across, right? To C5H12. I'm just going to put lines. Okay. That's one way we do the pentane. But I could also draw a pentane. It won't be named pentane, okay? But an isomer of that is I could put 4 carbons in a chain, right? And then I could branch off one of the middle carbons. It's still going to be, count up your hydrogen, but still C5H12. We would name it differently, right? It's going to be methyl butane. And this is another one where I don't have to say 2-methyl butane because the only place I could put the methyl group is off the second carbon. When that's the case, you don't have to put it there. And I could also do this. Still C5H12, but what am I going to name that? What's my longest chain there?
Or
Longest continuous chain.
just 3.
Just 3, right? It doesn't matter which direction I go, it's 3. So it's going to be a propane, right? And it's going to be a di. Propane, but if you count everything up, it's still C5H12. So those are all isomers of each other. Those are all isomers. So I'll just give you the rest of the period and work on stuff. If you come across something, have a question, just let me know.